Lata, guys, can you hear me? Yeah, so let's start the class. So today, we'll discuss about dynamic memory allocation. Okay. So what is dynamic memory allocation? What is static memory allocation? Can someone tell if you know? So what is the difference between static memory allocation and dynamic memory allocation? Hello. Yeah. So we have statically allocated memory concept that will be happened at compilation time. That is, if you see the example, that is arrays. So arrays will be allocated at compilation time the memory. So and this dynamic memory allocation, you will allocate the memory at runtime. So you will allocate the memory at runtime. Okay. So what is the difference between compilation time and runtime? So what is the advantages and what is the why we are going from static to dynamic? So if you take a array, okay, so we have 9 elements here. Okay, array length is 9 elements and index is 0 and last is 8 and you have values. So now if you have if you have a requirement that you need to increment the so at some situation you want to extend this memory, you want 5 more elements in the array, means you need 5 more integer elements. So can you do that at, it means can you extend at runtime, or means after, see first you have declared a int arr of 9, so can you extend it again? Can you extend it again? You can't do that. If you use arrays concept, you can't extend the memory. So whatever you are declaring or defining initially, that is fixed. So you can't extend at runtime when you have a requirement. And another case, you have 9 elements, means you have declared as 9 elements, but in some application you are using only 4 elements. Then remaining these 5 elements will be wasted. So 5 into 4 by 20 bytes is wasted. So means either your requirement will be more or your requirement will be less. If requirement is less, you will waste the memory. If requirement is more, you can't allocate the memory. Those are the two limitations of arrays, that is static memory allocation. To avoid this, we go for runtime memory allocation, where whatever the memory you want in the application running state, you can allocate that memory. That's why we are going from static memory to dynamic memory or runtime memory allocation. So this runtime memory allocation, unless you are freeing the memory, it will exist in the RAM. You know storage classes, right? All storage classes have lifetime. What about means lifetime means if you consider the RAM, we have covered stack, data segment and text segment. What about heap? Heap area will be allocated for dynamic memory allocation, and that memory, it won't expire, like it doesn't have any lifetime. It will having throughout the program, means process. You may have 100 files, then also it will exist in the 100 files. When it will be deallocated, when you do free only, it will be deallocated, or else it will exist. So if you are allocating the memory and if you are not freeing it, it will exist for a long lifetime. So which will leads to memory leaks, that we will discuss after the class. So first, now we will see the dynamic memory allocation. What are the functions we use to allocate the memory, and also how we can include that libraries. So in C, we have malloc, calloc and realloc. And free. These are 4 library functions which are used for dynamic memory allocation, and we'll allocate the memory at runtime. So if you want to, like printf and scanf, if you want to use in your program, for example, I will show you an example with that you will understand. If you see this example, if you see, if you run this program, so what will happen? It will give a compilation warning. See, implicit declaration of function printf. Why? Can someone tell why it is coming? Can someone tell why this warning is coming? Answer please. Yeah. So we are not using the header file for this particular library. Means printf is a function, predefined function. It was included from the stdio.h file. So for that you need to hash include stdio.h. Now if you run the program, it won't give any warnings. It will print the output, that's it. Same way, if you are using malloc, for example, int star ptr and ptr. Now I'm executing. You will get implicit declaration error. malloc. Implicit declaration for malloc function. Can someone tell what is the library function we need to include for malloc, calloc, realloc? Yes, correct. You need to include stdlib. So standard library where it will have malloc, calloc, realloc and free all the predefined functions. So if you include include stdlib.h. Now you won't see any error, any compilation warning you won't see. Why? Because you have included the stdlib.h. And guys, I'm giving a homework question. I think last time also I gave one. No, any homework program or concept. So I gave earlier and we were not discussed about it. Any homework, any pending tasks are there to discuss? So in this class, I'm giving a task, two tasks. So you need to come up with answers. Okay. First one is if you see this, okay, so if you see this example here, see, if you see this example, I'm doing one more thing. Okay. So string.h is another inbuilt library, predefined library. So what is the difference between this and what is the difference between this? If you know the answer, you can tell. If you don't know the answer, you can come up with answers for the next class. If anyone knows the answer, you can discuss it now only. You can tell it now. If you don't know, you can come up with answers for the tomorrow class. You know the answer, Sureka? Or else you can discuss on tomorrow. Okay. Yeah. Yes. User defined header file we use. Okay. Yeah. So the thing is, when you are using this left shift and right shift, okay, greater than less than. So when you use less than and so greater than, less than and greater than symbols, so which is standardly we use for standard library, predefined library functions. If you are including predefined libraries, then we go for this. And if you are using the user defined library functions like header files, then you can go for this double quotes, including the header file in the double quotes. And also one more thing we need to remember, if you are using this while including the header file, it will look up for that particular library throughout the entire project. So it won't restrict to that particular directory or its backward directories. అంటే ఆ path లో కాకుండా మొత్తం overall గా it will look up for the libraries where they have linked and where it is available. Whereas if you include this, it will search for absolute path, means wherever you are doing that compilation and everything, only in that particular location only it will search. In that particular component only it will search. If it is not available, this library function is file is not available, then it will throw error. Okay, so that is the another difference. So this we go for standard library function, and this we will go for user defined library functions. And here it will search for the particular library in all the project directories, but whereas this in the current directory only it will search. From the current directory only it will search. So you got the difference, guys? So now you got the difference between how you, means when you are including the header file, you can do both, but you need to prefer, if it is a header user defined library, then you will go with double quotes. If it is a predefined library, you will go with the less than and greater than symbols. So stdlib is, the purpose of stdlib is, if you want to include the malloc dynamic memory allocated functions, we need to use it. So the another task is, all of you know that compilation will be top to bottom and execution will be from main always. For example, you have three functions and one main function, overall four functions. Main is calling function 1 and function 1 is calling function 2 and function 2 is calling function 3. Correct? Now I want to execute the program not from the main function. I want to start the execution from some other function instead of main. Is there a possibility to do that? If you have, you can come up with answers. So execution always starts from main, but I want to start with some other function. Is it exist in the C programming? If exist, how you can do? Clear, guys? Question you understand, right? Question is clear? If question is clear, even though you are not telling now, I am okay. I will proceed to next concept. You can come up with answer for tomorrow class. startup code underscore. I want a little bit more. Yeah. I want more descriptive about that. Okay, so we'll discuss it tomorrow. Okay, so you need to explain that, Sureka. So if you are not explaining, so then we'll see. I will explain. You come up with more descriptive. Okay, so some with if you have a program, right, you can copy paste in the chart window and you can explain. Okay. So now the coming to dynamic memory allocation. So we have four, right? malloc, calloc and realloc. Last one is free. See, these three are used for memory allocation, and sometimes this one we will use for deallocating the memory. Even sometimes we can deallocate the memory by using realloc. So that also we will explain how we can do that. First one is malloc. So what is malloc? malloc is a memory allocation and it will allocate the memory, the value which is provided in this argument. It will have one argument. Okay. And so that whole memory will be created as a single block. How? And coming to syntax. So yeah. So this is malloc. Here we need to specify the size number of bytes you want to allocate as a block. And coming to that structural representation, pictorial representation. So malloc you can use like this. So why you are using typecast? That is one question. And you are allocating the size as 5 into size of int. Consider size of int is 4 bytes. 5 into 4, 20 bytes memory you are allocating. That whole memory will be created as a single block. A large 20 bytes memory block is a dynamic related to PTR. Now PTR will points to starting address and it will have up to 20 bytes. Correct? So this is how malloc will allocate the memory. Why we are using typecasting? Why we are using typecasting? Can someone tell why we are using typecasting? Yeah, so typecasting is required because malloc, if you see this malloc, so it will return some value. So this function, this is a library function, right? This function will return a value that is pointer and it is void pointer, means it will return the void pointer. So in order to assign as per our requirement, we need to typecast to particular specific data type. So that's why whenever you are using not only malloc, calloc, realloc, all three will return the void pointer as the return type. So when you are doing that, you can do typecast. Now see this example program, how we are allocating the memory. Okay, by using malloc. See, now I have a pointer and I have two integer variables and then I am taking 5. Okay. So number of entered number of elements are 5. Now I am allocating a size for this PTR, which is pointing to store n is 5 and size of n 20 bytes. It is pointing. If in heap area, if you don't have 20 bytes of memory, the malloc is failed because insufficient memory or something, then it will return null. If PTR is equal to null, then your memory allocation is not successful. Okay, your memory allocation is not successful. If it is returning some valid pointer, valid starting address creation is successful and it will be created as a single block of memory. So you are storing the value. So PTR is a pointer, right? You can use the index PTR I, or you can write this. Remember PTR plus 1. So you can write like this. Both are same. So you are printing those values. Since PTR also, you can consider PTR is an array, then it will store the starting address of value. When you increment that, it will be the next element. So you need to understand from this program how we are allocating the memory, and you need to check always whether memory is created or not. If created, then you need to access the memory. If not created, then it will lead, you need to return a error message, and you will return. So memory is not successfully allocated. This is about malloc. In this program, okay, this particular pointer and these variables, if you see this, okay, this PTR you are not assigned to some address, local address. You are assigned some runtime memory. You are not allocated a compile static time memory. If you are allocating address of I to PTR, then it is a static assigned memory. If you are allocating the memory through malloc, then it is dynamic memory, that is in heap area. So now if you see this example, I am not allocating the memory through PTR. PTR equal to address of I. So once this program execution is completed, okay, then this all variables will be, ultimately it will be into out of lifetime. So the memory will be allocated and it will be freed automatically. It will be deallocated based on these storage classes. When coming to this dynamic memory allocation, after completion of this program, PTR is allocated through dynamic memory allocation. Because of that, if after completion of this program, it won't automatically deallocated from the memory. So runtime memory, you need to always free it. So if you free after usage of your memory, then the memory will be deallocated. And you know one more thing, after allocating and deallocating, we need to assign to PTR equal to null. Why we need to assign PTR to null? Can someone tell why we are assigning null to PTR? I already explained. Why? See, after freeing the memory, it will be anyways deallocated the memory. Then why I am using PTR equal to null again? Yeah, to avoid dangling pointer. Yes. So PTR అనేది dangling pointer కాకుండా మనం null కి assign చేసేస్తాం. With that PTR won't point to any memory location. So this you need to practice. So in even real time also you need to follow this coding guidelines. So this is about malloc. So it will allocate a memory into a single block like this. Single block memory. All the memory location, you need to remember one more thing. When you are allocating the memory, in memory some value will be there, right? That value will be garbage value if you are allocating the memory through malloc. So malloc, when you are allocating the memory, it will have default value as garbage values. Okay, this is about malloc. Whereas coming to next one, that is calloc, contiguous allocation. So calloc, what is the abbreviation of calloc? Contiguous allocation. C means contiguous. So how it will allocate the memory? So calloc will have two arguments. First one is you will have two arguments. First one is number of blocks, and this is size of each block. Means here you have a single block in the malloc, whereas in scalloc will have number of blocks, different, more than one block, and which it will have some size. So that I will show you. See, in calloc, so it will, you need to typecast. Why? Because this calloc also will return the void pointer, and you are passing two arguments, 5 comma size of int. Whereas in malloc, it's a single argument. See, multiplication will return some value, that is a single argument. Whereas here you have two arguments by separated by comma. First one is number of blocks, second one is size of each block. Now PTR will points to 5 blocks and each block size is 4 bytes. 5 blocks of 4 bytes each. Okay, that will be allocated at runtime. And one more thing you need to remember here. So the values, when you are allocating the memory, it will be initialized, the default values will be 0. Whereas in malloc, the default values are garbage. Okay, so this is a contiguous memory location which will be divided into multiple blocks. Through argument, it will specify number of blocks and block size of each is block size. So this is calloc. So you can follow either of two. What based on your requirement, if you want to have a memory with initialized 0 by default, you can go with this. So and one more, so up to now, is it clear, guys? Till now, is it clear? Okay. Now, can someone tell which is faster? malloc is faster or calloc is faster? malloc is faster. Okay. malloc is faster. Can you say why? The reason? Yes, correct. malloc is faster. malloc is faster. Yes. Yeah, the reason is correct. See, actually, there is no much difference. Okay, like malloc is 1 second and calloc is 2 seconds. It won't be that much difference. It will be fraction of some milliseconds. Only that difference will be there, because so that extra process will take to divide the memory into blocks and allocating. And another reason is it needs to initialize the values with again zeros. So just it will declare the memory, and also it need to initialize the memory with 0 value. So that is the extra burden to calloc process. Okay. Next one is realloc. So so now till now, so you understand malloc and calloc and the difference between malloc and calloc. Now coming to realloc, what is the usage of realloc and why we need to go for realloc? What is the use of realloc and why you can go for realloc? Is there any advantage? Okay, yeah. To reduce the size of block when not in use, memory, yeah. You can reduce the size when they are not used. Yes, correct. And you can expand also. Okay. Is there any other advantages? Yeah, so it will real, yeah, it will real. So the reason, see, for example, you have allocated a memory through a pointer with 20 bytes of memory. Now you want to extend this memory, means you want to you need 20 more bytes. So if you want that, so you can use another pointer and you can do again malloc, or else you can use 40 directly. Instead of taking two pointers, you can do free of ptr free of ptr1, and again you can allocate ptr1 equal to 20 40. So with this, right, it takes extra burden. You need to free it. Again, you need to allocate the required number of bytes. And when you are allocating this, you may access the some other memory location also. Whatever the available memory location, it will give. Whereas coming to this, if you are using the realloc, so it will just extend the memory with whatever the existed. For the existed memory, it will extend 20 more bytes or 30 more bytes or 40 more bytes. Anything you can give. So how many bytes you want to extend, that value you need to specify. So this is the example for calloc. Calloc also will return null if the memory is not sufficient in the heap area. And coming to this is a realloc. This is realloc. Sorry. Yeah. First you are allocating the memory by specifying 20 bytes, and it is successful. Okay. Now you want to increase the number of elements to 10. Now you don't need to remove that and allocate again for 10 elements. Directly you can call realloc ptr comma n 10 into size of. So this size should be overall size we need to specify, but address will start from the previous location only. For example, in this example, previously you have allocated 20 bytes. Say you have ptr is pointing 1000 and end value is 1020. Now when you are doing reallocate, the memory will be like from 1000 to 1040. So from same memory, previous memory and additional memory will be expanded by using realloc. If the memory is not available, realloc also will return null. If memory is available, it will return a starting address of after reallocation. So that is how you can do reallocation. And what? So next one is free function, deallocating the memory. So you just simply you have allocated the memory to PTR and PTR1. Okay. and after using the memory, you are just freeing PTR and PTR1. Free, how you can use? Syntax is just free won't return anything, that is void type. Free, and you need to pass the PTR. This is the syntax. Now I have to explain three things. First one is memory leaks. Second one is how free function will work. Okay guys, so questions are, first one is, okay, what is memory leak? How to avoid it? Second one is how free function will work. Meaning is, see, for free you are specifying the size of starting address. How it will remove the number of bytes exactly that was allocated by calloc and malloc. See, in the calloc, malloc, you are specifying 20 bytes of memory you are allocated. When you are freeing, you are just passing the 1000 address. How it will know the boundary? Means how free function knows up to 1020 only the memory locations from 1000 to 1020 needs to be deallocated. How it will know the boundary? That is one question. Another question. And last one, is there any possibility to deallocate the memory other than free? Can free the memory, deallocate the memory without using free in a C programming? These three are the important questions on the dynamic memory allocation concept. Clear guys? So what is memory leak and how to avoid it? Memory leak is when you are allocating the memory runtime dynamically by using malloc, calloc and realloc. And after using the memory, after accessing the memory, once you have done with that memory, if you are not freeing it, then the memory will be existed um, as a allocated memory for long time, and that memory cannot be useful for another resources. So with that, the memory will be wasted. Even though you are not using the memory, but it is not giving the availability for other resources. It's a wasting, you are wasting the memory. So memory is a critical resource in RAM. Since the RAM size is very limited, the memory, even 1 byte, less than 1 byte, also very crucial part in the RAM performance. If you are wasting, see, one file you forgot to deallocate 4 bytes, another file 4 bytes. Like that, if you are missing it in the 100 files, then what will happen? The memory will be huge. So after, whenever the requirement, that resource is handled successfully and you don't want to use that memory again, then you need to free it immediately. If you are not deallocating, then it will lead to memory leak. If you want to avoid it, you need to free it after using the memory. So this is about what is memory leak and how to avoid it. Yeah, so heap memory, if you are not deallocating, it will exist for like that. That cannot be used other by other programs or other resources. Please remember. Is it clear, guys? Memory leak and how to avoid it? Yeah, that I see. One thing you can do, Sudhir, actually, how you can see, you can just walk through the code. I will show you one example. If you see this program, I will remove everything. So with that, you won't see any other things. Do you see any memory leaks in this program? Can someone tell? Do you see any memory leaks in this program? Guys, do you see any memory leaks in this program? Any other answers? Yes, it is having memory leak. Just by observing this program, you can say. Simply, if you observe the program, see, you can't do this for real time. Means by walking all the code, you can't decide. Why? Because there will be thousands of files and thousands of line of code. You can't go through manually. Okay. See, for simple understanding, I am explaining with this simple program. You are allocated the memory of 20 bytes, and you have used that memory and you access the values. After that, directly you are returning 0. So if it is a global variable or it is a static variable or it may be local variable, once the program completion execution completes after this block, so the memory automatically it will freed in the RAM. But when you are allocated through dynamic memory allocation, until unless you are freeing the memory, it will leads to memory leak. So before returning free, you have to do PTR and PTR equal to null. If you do this, then memory leak is not there. And if you observe this program, If you see this program, is there any memory leaks in this program? Once you are allocated, yeah, that we can do. Yes, you can do that. PTR equal to null and PTR1 equal to, this is just to avoid the dangling pointer, but there is no memory leak. So there is no memory leak. Okay, clear guys? Is it clear? Yeah. The next question is how free function will work. In the free function, you are passing just one argument, that is starting address of the pointer, and how it will know the boundary and how it will free that exact number of bytes. The answer is, when you are allocating the memory for specified number of bytes by using malloc, calloc or realloc, the memory will be allocated 4 bytes extra or 1 word extra than the required number of bytes. For example, if you are allocating the memory of 20 bytes, so actually it will allocate 24 bytes, and in 4 bytes, okay, it will store the address size, how many bytes it has allocated, and based on this extra word, when you are freeing that value, it knows, okay, so starting size is this and number of bytes it was allocated will be stored in the 4 bytes of word, right, first word. So based on that, it will know the value and it will remove that many number of bytes only. So when you are doing memory allocation, malloc or calloc or realloc, it will create the memory 1 byte, one word extra. That is, 1 word means 4 bytes in 32 bit. In 16 bit, 1 word is nothing but 2 bytes. Please remember, 1 word are 4 bytes. So that memory will be extra created in order to store the memory how much we are creating through malloc or calloc and realloc. Is it clear guys? You understand how when you are freeing the memory, how exactly it will deallocate the memory. So actually you will have a memory creation, it will be created in the chunks. Okay, so there it will taken care of the memory allocation and it will allocate extra 4 bytes in the chunks. And coming to next one, other than free, can you deallocate the memory? Is there any possibility? Guys, answer please if you know. Using null pointer. Yeah, null pointer, what will happen if it will points to valid address, correct? But the memory, whatever you have assigned through memory allocation, right? That won't be deallocated. So using null pointer, what you can do, you can change the address to null value. But the address, no, why, for example, you have created to 100 bytes, like 1000, 2000, 1100. Okay, that memory is allocated through then some dynamic memory allocation. Now you want to free it, you want to deallocate it. Now, for example, PTR is pointing to 1000, you are making PTR to null. What is the meaning of it? Your PTR is pointing to nothing, but 1000 to 2000, 1000 to 1100 value is still exist in the memory. It is leaking into memory leak. So you can't avoid. Means you can't deallocate the memory, but you can point to some. It won't point to any other address. But what is the meaning of dynamic memory allocation? Once you have allocated, you need to free it. You need to deallocate it. So null pointer is the not correct answer. Any other answers, guys? This question was asked in many interviews in the recent time. So HCL, they have asked Harrison, Altran, TCS, means Tata Elxsi. So many companies, yeah, realloc. Correct. How you can do? Yeah, realloc, by using realloc, you can deallocate the memory. Can you tell how you can do? Can you tell how you can do? Realloc is correct. So can you tell how you can do that? You can do same thing, like you need to pass. So instead of free, right? Same thing you can acquire by using realloc. Okay, and ptr comma 0 you need to pass. If you do this, it will do the equal functionality of free. It will do the equal function of free. Whatever it will do, same thing will be done by using a realloc of ptr comma 0. Clear, guys? Is it clear? Okay. So now this is about dynamic memory allocation, guys. So what is dynamic memory allocation? Why we are going for from static to dynamic? What are the advantages? And what are the ways to allocate? What are the ways to allocate the memory? Okay. And next one is so difference between memlock and clock. So and how realloc will do, and what are the advantages of realloc, and how you can free the memory, and how free function will work, what is memory leak and how to avoid it, and this one, what about yeah, so other than free, is there any other ways to deallocate the memory? These are the questions, okay, on dynamic memory allocation you need to study. So topics are covered and questions also covered. It's about dynamic memory allocation. Okay, so now we'll move on to next concept. So we'll start with which one we'll start with? Bitwise operators are there. Structures and unions, yeah. I think it's better to start with bitwise operators. Why? Because structures and unions will go in a flow. Like structures and unions, after that will go to directly linked list. So like data structures. Then after we'll go to the last concept is strings. Okay. So we'll go to the next concept as bitwise operators. So bitwise operators are very important concept in our domain. Why? Because the data, whatever it will come, right? The packets and everything. Finally, the data will be in zeros and ones. If you want to manipulate the data, you need to know the bitwise operators and how you can manipulate. Without that knowledge, you can't do anything. So the data communication itself, the data whatever, for example, you are sending a hello message from my laptop, from my WhatsApp to your WhatsApp, or from my Messenger or Facebook to your Facebook. So ultimately, once the data is started, the communication from your source, means that physical layer, it start from zeros and ones, the communication will happen, and once it is reached this, then they will reassemble the data and the original message will be given to the receiver. So this process, if you want to understand, you need to know about the bitwise operators, how you can manipulate the data, how you can see that particular bit is set or unset. ఒక బిట్ ఉంది, ఆ బిట్లో జీరో ఉందా వన్ ఉందా ఎలా కనుక్కుంటావు? ఒకవేళ జీరో ఉంటే వన్ చేయాలి, వన్ ఉంటే జీరో చేయాలి, ఏం చేస్తావు? ఓకే, వచ్చేది లిటిల్ ఇండియనా లేదంటే బిగ్ ఇండియనా? డేటా అనేది లిటిల్ ఇండియన్ ఫార్మాట్లో ఉందా, బిగ్ ఇండియన్ ఫార్మాట్లో ఉందా? లిటిల్ ఇండియన్ బిగ్ ఇండియన్ అనేది ఎలా అంటే, ఇప్పుడు మనం మెమరీ ఉంది, మెమరీలో మనం వాల్యూ స్టోర్ చేస్తున్నాం. ఆ వాల్యూ అనేది ఏ ఆర్డర్లో స్టోర్ అవుతుంది? లోయెస్ట్ బైట్ నుంచి హైయెస్ట్ బైట్కి అవుతుందా, లేదంటే హైయెస్ట్ బైట్ నుంచి లోయెస్ట్ బైట్కి స్టోర్ అవుతుందా? కొన్ని సిస్టమ్స్, ఇప్పుడు ఇంటెల్ ఉంది, ఇంటెల్ ప్రాసెసర్ విల్ ప్రాసెస్ ఇన్ వన్ ఆర్కిటెక్చర్, దట్ ఈస్ లిటిల్ ఇండియన్, and another processor will be there that will be stored in the big Indian, IBM, some other process. So that will be vary how the data is stored in the memory, that is little Indian big Indian concept. So that we need to study. If you have received the little Indian but your system will understand big Indian, what you need to do? You need to convert the little Indian to big Indian format. Same way in reverse also, if you received a big Indian but you will understand only little Indian, then you need to convert it. That conversion you need to use bitwise operators. So many things are involved in the bitwise operators, and this concept is very important. So in the interview also. Clear guys? Any doubts? You have any doubts? Okay. So what are the bitwise operators we have in C? In the initial classes, we were discussed a little about bitwise operators. So what are those? Okay, bitwise and bitwise R. Okay, bitwise XR, and this is negation, inversion, inverter. Then this is left shift, right shift. These are the bitwise operators we use in C programming. Okay. Why I am telling bitwise only? Why? Because we have in logical also we have operators, and so here you don't need anything. XR, this is R. Inversion. Left shift. right shift. Is it clear, guys? These are the operators we have in C, and we need to know the truth tables. Truth tables. So since these are bitwise operators, the operations will be performed in bits only. So truth table is this is truth table of AND. And this is truth table of R, and this is truth table of XR, and inversion means 0, 1, 1, 0. Okay, for this we have two tables, whereas left shift and right shift we use for separate purpose, different purpose. So based on this, right, we will evaluate some statements and we'll note down. So you need to be very clear with those statements. Okay, so I will start. So I will write this side. So based on the truth table, you can tell. This is very clear, useful, guys. If you know this, you can perform, you can write any program in the bitwise operators. Okay. X R with 0. So if X is a test bit, it may be 0 or 1. When you are performing R operation with 0, so what will be the output? What is the output, guys? When you perform X with R operation with 0, so output what is the value? 1. How it will be 1? X may be 0 or 1. If it is 0, 0 or 0, that is 0. If it is 1, 1 or 0, 1. The meaning is 0 or 1 means if X is 0, output is X 0, that is X. If X is 1, output is 1. The meaning of the statement is it is equivalent to X. X ఏదైతే output కూడా అదే. Correct, guys? You have any confusions in that? X if you consider 0, output is 0. X you consider 1, output is 1. Meaning X ఏమనుకుంటే అదే value output వస్తుంది. Now X R with 1. Now tell me what is the output. X 0 అయితే ఏం అవుట్పుట్ వస్తుంది, 1 అయితే ఏం అవుట్పుట్ వస్తుంది? ఎస్, X 0 అయినా 1 అయినా అవుట్పుట్ 1. కరెక్ట్. Now what about X R with X? X R with X means 0 0 1 1. Yeah, so the output is 1. Correct. That sorry, X. And what about this? What is this? X and X dash. X R with X dash. X dash means X 0 అనుకుంటే X dash 1 అవుతుంది. X 1 అనుకుంటే X dash 0 అవుతుంది. What is the output, guys? X and X dash. X dash. X and X dash. It is 1. Correct. Yeah. So it is equal to 1. Why? If you consider X as 0, 0 or with 1, that is 1. If we consider x is 1, 1 or with 0, that is 1. Clear, guys? Understood, right? This you need to be clear. Next one is, we'll start with AND operation. X and 0. So what is the output, guys? Can you hear me now? Okay, fine. Yeah. So x XOR with x. What is the output? So if you take this XR, so you look up for this XR table and X with X, when you do X XR with X, what is the output? X is wrong. You can interpret the table. Yeah, so the value is 0. If you take any XR operator, if both the inputs are same, then output is 0. See, both are same, 0. If both are different, then is 1. Means both are zeros, 0. Both are ones, 0. Next, X XR with X dash. What about this? Yeah, if inputs are different, the output is 1. Yes. These two tables you need to be see ఎప్పుడు అడిగినా ఏది అడిగినా చెప్పగలగాలి. అప్పుడే మీకు బిట్వైజ్ ఆపరేటర్స్లో ప్రోగ్రామ్స్ మీద మీకు ఐడియా వస్తుంది. లేదనుకోండి ఆ లాజిక్ ఏం అప్లై చేయాలో మీకే రాదు ఐడియా. ఇవన్నీ క్లియర్గా ఉంటే ఓకే ఇది చేస్తే ఇది వస్తుంది, ఇది చేస్తే ఇది వస్తుంది, దాన్ని బేస్ చేసుకొని మీకంటూ ఒక ఐడియా వచ్చి లాజిక్ రాయగలరు. అలా కాకుండా జస్ట్ సింపుల్గా ఇవి గుర్తుపెట్టుకోకుండా ఉండాలనుకోవచ్చు. ప్రతిసారి మీరు ట్రూత్ టేబుల్ పోయి చెక్ చేసుకొని ఏది మనకి సూట్ అవుతుందో అదన్నీ చూసుకోవడం కన్నా సో డైరెక్ట్గా ఈ 12 స్టేట్మెంట్స్ మీకు గుర్తుండాలి. ఈ 12 స్టేట్మెంట్స్ గుర్తుంటే మీకు సో ప్రోగ్రామ్ రాయడం ఈజీగా ఉంటుంది. సో టిల్ నౌ వీ హ్యాడ్ సీన్ ద బిట్వైజ్ ఆపరేటర్ ట్రూత్ టేబుల్స్ అండ్ స్టేట్మెంట్స్. Bitwise operator truth statements. So now, and all of you know that if you do int x equal to 10 and if you do x equal to x left shift 1 comma y equal to 40, y equal to y right shift 1. So what is the output, guys? What is the x value and what is the y value after doing the left shift by 1 bit and right shift by 1 bit for y? This we have discussed in the bitwise operator concept already, so that's why I'm not explaining. If you are telling, if all of you clear, then I don't need to explain. X equal to 20 and y equal to 20. Yes, correct. Yeah. All of you know that left shift we use for multiplication purpose and right shift we use for divide purpose. When you do x left shift position equal to x into 2 power position. This is one statement. Another statement is x left shift, not right shift position is equal to x by 2 power position. If you apply this syntaxes, this formula, so you have 10 left shift 1. So 10 into 2 power 1. 2 power 1 means 2. 10 into 2. So that will become 20. And y, coming to y. So x right shift 1. So that is 40 by 2 power 1. That is 2. 40 by 2 is 20. And if you want to see example how it was happening, what is 10? I am considering 1 byte. 1 0 1 0. If you do left shift, what is the meaning of left shift? What is the meaning of left shift? So it will be coming here. this position will be moved to left side, your left hand side, and this is 0 and this is 0 and this is 0, and here this is 1 and this is 0, and this 1 bit will be coming to next position, that is 1 and 0, and leftover bit will be set to 0. So with this 2 power 0 into 0, 2 power 1 into 0, 2 power 1, 2 into 1, that is 4, and 2 power 3 into 0, 2 power 4 into 1, that is 16. 16 plus 1, 4, 20. So x is becoming 20. This is left shift. When you do right shift, you need to take y value as 40. So you can take y value as 40. What is 40? Bitwise operator 40 value. What is 40? Bitwise operators, what is the representation of 40? I need the answer. 1 0. Yes. Yes, correct. 0 0 1 0 1 0 0 0. This is bitwise representation for 40 value. Integer 40 will be represented like this. If you want to do, you can do 2 power 0 is 0, 2 power 1, 2 power 2, 2 power 3. 2 power 3 means 8. 2 power 4, no, 2 power 5, 32. 32 plus 8, 40. Right shift means, what is right shift? So this 0 is coming to here and 1 is coming to, another 0 is coming here, 1 is moving here and 0 is coming here and 1 is coming 0 0, and leftover bit will be set to 0. Now tell me what is the value of this? 4 plus 16. 16 plus 4, 20. So x divided by 2. Yeah. So you are clear with this? Left shift, right shift, and right shift, left shift, and these two tables. Okay. So we'll see some simple programs. We'll see some simple programs like today. So I will start like 2 to 3 programs. Then remaining we will cover in the next class. There are some other concepts. Before going to the programs, I think it is better to cover the theoretical concepts first. Okay. Yeah. So now we'll study about Little Indian and Big Indian Mission. So Little Indian and Big Indian Mission. So anyone knows about what is Little Indian Mission and Big Indian Mission? Yes, guys. So memory allocation, yeah. So what is Indianness first? Indianness. Actually, Indianness tells when you have a multi-byte data, like if you consider integer, float, double. Okay, not character. Character is a single byte. So if you take a multi-type data, so how the data will store in the memory, it represents the Indianness. Based on this, we have two types. One is Little Indian, another one is Big Indian. How they will happen, how they will do, let's see. Consider you have an integer variable. Take an integer variable int x equal to, considering instead of integer variable, I'm considering a 16-bit value, that is hexadecimal representation. Each hexadecimal will require 4 bits, right? 1, 2, 3, 4, 5, 6, 7, 8. You have 8 hexadecimal digits, 8 into 4, 32 bits. So this x is a 32-bit value. 32-bit value means 67 is 1 byte. Okay, 45 is 1 byte. 23 is 1 byte. 01 is 1 byte. So 4 bytes, right? Now if you take this value, integer value, how this value will be stored in the memory? In memory also you will have memory locations like 1000, 1001, 1002, 1003. You have four bytes are required, right? So memory in this value, will it store from 1000, means 01 will be stored here, 23 will be stored here, 45 will be stored here, or 67 will be stored here, or in reverse order. Means 67 will store here, then 45 will store here, then 23 will store here, and 01 will store here. If it is a little Indian, it will store in one way, and if it is a big Indian, it will store in one way. If you take a little Indian, so if you take this, what is the lowest byte and what is the highest byte? LSB and MSB. If you take this, what is the LSB and what is the MSB? Consider you have a memory location 1000, 1001, 1002, 1003. Correct? And in the little Indian, the value will be stored. It will be stored in the 0, 1, 2, 3, 4, 5 and 6, 7. And if you take here 01 will be stored in the 1000, and 101 it will be stored in the 23, and 102 it will store 45, and this will store 67 here. Is it clear, guys? So if you take these, in the little Indian means the lowest order byte memory, in the lowest order byte memory will be stored. If you take this, I will show you with an example. So in this, what is the LSB and what is the MSB? If you take this is LSB and this is MSB. Everyone knows that LSB and MSB, right? Least significant byte and most significant byte. Least significant bit and most significant bit. So this is how it will be. So even though memory representation, actually you will have like this. If you take 1000, 1001, 1001 and 1000, if you take memory location of 4 bytes, so this is the least and this is the most. You know that there is no difference, right? Least means starting value, most means ending value. And here in this value, this is least and this is most. So 61 will store here. 67. and 4, 5 will be stored here. And 2, 3 will be stored here. And 1, 0 will store here. This is how stored in the little endian. Least byte will be stored in the least byte memory. Least byte data will be stored in the least byte memory, and most byte value will be stored in the most byte of memory. This is little endian. Whereas coming to big endian, here it will store 67, and here it will store 45, and here it will store 23, and here 10. So lowest byte data is storing in MSB byte, most significant byte, and most significant byte is storing in the lowest byte. This is clear, guys. Based on this, if you see this example here, you may get some confusion. Why? Because the memory address always start from left to right, 100, 101, 102, 103. Like this, the alignment will be there. So, and if you consider here, if you're considering here, this is LSB and this is MSB. So in the little endian, LSB first storing and MSB next storing. In big endian, so LSB is storing in the MSB, and LSB is storing in the MSB is storing in the LSB. Clear, guys? This example and this one. You are clear with this example? Now I am considering one more example, guys. Now tell me. Now I need the answer. In LSB, what will be the value? Now tell me the values. So I have the data as this, and tell me the answer. For little endian, how the data will store, and big endian, how data will be stored. So 0, 0, 0, 0, 0, 1. Yeah, 1, 0, 1, 0, 0, 0, 0, 0. Yes. Okay. Yes, the answer is correct. So in the lowest order byte, so you are storing the lowest order data, that is 0, 1, and this is 0, 0, 0, 0, and 0, 0. See, actually, here you are considering the data as LSB to MSB. Same way, you need to write the memory address also LSB to MSB. Then you don't get any confusion. In this example, you have from LSB starting here and MSB here. But as you know, LSB will be here and MSB will be here. So for that, you need to write the memory location in the same way. Then you won't get any confusion. Okay. And 0, 1, 0, 0, 0, 0, 0, 0. Okay. With these examples, you are clear, guys? Clear, guys? With this example, you are clear about Little Indian and Big Indian, right? So, okay. And so there is no more theoretical concepts in bitwise operators. So we'll start the programming. So the programs are like how to set a particular bit in a given number, how to unset, how to toggle, okay, and how to find whether the bit is 0 or 1, number of on bits, number of ones and number of zeros in a given number, okay, is given number is power of 2 or not, okay, and nibble swapping. Nibble means 4 bit swapping in a word. Nibble means 4 bits. 1 byte means 8 bits, right? Nibble means 0101. You have 1010. Now nibble swapping means output should be 1010 0101. This is nibble swapping. And byte swapping programs. Okay. And little Indian to big Indian conversion and big Indian to little Indian conversion. And how to find a given machine is little Indian or big Indian. So these programs are there, so that we will start in the tomorrow's class. Okay, so first we will complete the programs, all the programs, and important means we need to cover all the basic programs as well as interview point of view. All we will cover in the next class. So if you want, you can go through some bitwise operator programmings in means through Google. You can go and you can get some hands-on programming before coming to the tomorrow's class. If you want, you can go. Okay. Anyways, we will discuss also. Clear, guys? Any doubts? Till now, you have any doubts? These are very, very important, guys. Whatever we are discussing, right? Today's class, dynamic memory allocation as well as bitwise operators. These are very important, very, very important. So, okay, guys. So we'll meet tomorrow. Okay. So like today's, please be available by 7 o'clock early. Anyways, tomorrow weekend, right? You can start little bit more also, little bit early also. Is it fine, guys? What is your preferable time, like 6 to 8 or 7 to 9? 6 to 8 or 7 to 9? 5 to 7, I'm not sure because I may have some interviews. If I am having interviews, then only problem, or else no matter. We'll see. I will inform you tomorrow morning whether it will be 6 to 8 or 7 to 9. Okay. Based on that, you please available. Okay then. So tomorrow and so I will call you each person individually, and we'll discuss about your progress and where are you with the preparation and everything, and how the discussions were going on in the group. So you need to respond. If you people are not yet started, right, then it won't be good. The discussions in the group, if you people not yet started, then that shows your interest. Okay, that also I will ask on tomorrow. I will ask tomorrow. Okay, everything. So you can come up with your whatever you want to discuss. It may be regarding to the course or it may be regarding to the interview point of view. Anything you can ask. Okay. Okay, guys. We'll meet tomorrow. Bye.